Hi, my name is Tristan Corey, that's me, and today I am here to talk about GALA, also known as the Ganymede Laser Altimeter. This is an instrument that is on the JUICE probe, as seen here, JUICE being the Jupiter Icy Moon Explorer mission, which is slated to start later this uh, decade in terms of scientific goals. It's already been launched, and recently, in August, performed a flyby of the moon. So this is a picture of the instrument, and without further ado, let's get on with it. So what is GALA? As stated, GALA is the laser altimeter on the JUICE mission, and one of the main goals for this, since it is a altimeter, is to measure altitude data along Ganymede's ice crust, as well as search for more evidence supporting the idea that there's a subsurface ocean on Ganymede, and characterizing that a little bit better. So, in order to be able to accomplish these objectives, the probe will be sent to Jupiter and perform some flybys of its icy moons, including Europa, Ganymede, of course, and Callisto. And that will happen around 2034, so pretty late into the mission. And the last objective is to orbit Ganymede and take some readings in a polar orbit at around 500 kilometers. So, just for comparison to show, this is Ganymede in the bottom right corner. As you can see, it has a much larger saltwater ocean part of its composition when compared to Callisto or Europa. Eo's just here to be here, but yeah, so this makes Ganymede a especially great target for research of things that we might find or we might suspect to find in the water on other planets, or in this case, in Jupiter's moons. Potentially signs of life, since we know that water is one of the requirements for that. And specifically, the evidence for microbial life, like what we're hoping to find on Mars. But maybe we find some living things too, in the form of extremophiles in Ganymede. And that's sort of the same idea with Europa or Callisto, but because it's a much larger saltwater ocean, the chance that there might be something there is potentially heightened. So, just to restate some of the scientific objectives, the main idea is to characterize the surface and subsurface ocean of the moon, as well as understand sort of what's happening on it in terms of qualities like albedo, surface roughness, things like that. So how does the instrument work? So if you take a look on the left, I know it's a little bit crushed, but this image is essentially a flowchart showing how it works. So there is power supplied on the probe that is fed to the laser. This laser then sends out a signal to the moon's surface, and then it's received back. This is received back by a telescope, the receiving telescope, 25 centimeter aperture, and there's some smaller optical components that work to convert it into a readable signal. That's what this is describing, is analog electronics, and essentially makes it so that the signal can be interpreted along with some of the metadata, including things like the delay between when the signal was sent and received, as well as the return pulse intensity of the beam. So essentially, the delay is used to measure the altimetry, wherein the time it takes for the pulse to be sent and returned can be used to determine the height at a point along the probe's ground track, which helps characterize the height of certain surface features, whereas certain qualities of those features is determined by the return pulse intensity, things like albedo and slope and roughness, with albedo being of key interest because it is essentially how much energy is returned back into space by the surface. So that's of key interest on something like an icy planet, or in this case, an icy moon. So yeah, that's essentially what I have. I hope you learned something about this cool mission with me today, and yeah, these are some of the resources that I used. A lot of it's pulled from NASA or from the German Aerospace Center, since they worked a bit on this, since it's an international mission. But yeah, hope you learned something, and thank you for your time. Thank you.